Hello, my name is Mawad Zubir bin Bahar, and in this video I will introduce you to the hydrostatic force on a plane surface. Okay, first of all, when we talk about force given by a fluid, so every time we need to determine three things. Number one is what is the magnitude of that force. Okay, so we are looking for the magnitude, the magnitude of the force. Number one, you're always looking what? Magnitude. Followed by the location, and number three is the direction. So please remember, every time when we talk about a force given by fluid, you must determine the magnitude, you must determine where is the location of that force act on the surface, and also what is the direction. Okay, so in order to know what is the magnitude and what is the location and what is the direction, so we need to understand the basics of the hydrostatic force. What is the basic of it? Okay, so first of all, let's draw. Let's say you have a fluid in equilibrium, in aquarium, for example, and then let's assume you put a plane surface, with an angle of theta. So you have a plane surface there. Okay, that is your plane surface with an angle of theta. Okay, when you see from a side. Okay, so if you see it from the front, if you see it from the front there, okay, probably your plane surface actually having its quite weird form. Quite weird form. So in other words, it doesn't matter how the form look like, but the most important thing is the surface must be plane. It must be plane, and all the bodies, all the body must have their own center of gravity. So let make the assumption the center of gravity of this particular plane surface is at this point, okay, at the CG there. Okay, so if you draw, probably you say, okay, on the free side, on the side, probably you say, okay, your CG actually is somewhere here, so we call it as the point of CG, center of gravity. Okay, and let's make the assumption. So the distance from the CG, if you measure it vertically, when you measure it vertically, okay, you measure vertically, and the distance is call it as the h bar. Okay, so we call it as the h bar. Okay, the distance we call it as the h bar. Write it as the h bar there. Okay, now we know that on this free surface there, we have PATM with a value of 101.3 kilopascal in terms of absolute. So this atmospheric pressure was forcing the free surface of the water, and of course the water will also give a forces or the pressure to a plane surface, and we know that the magnitude of force, the magnitude of force at the top here must be smaller compared to magnitude of force at the bottom there, right? Why? Because we know that when you go deeper into the fluid, the pressure must be higher. It become higher and higher. Of course, the force will become higher too. Okay, so now if you want to know what is the magnitude of these forces given by fluid to this plane surface here, you know that the value keep on changing linearly from the top to the bottom. Okay, so in other words, in order to know what is actually the magnitude of force acting on the surface here, actually we are looking for the average force. So in order to determine the average, so we need to go by what we call by element. So we take some element of area here, element of area there, Okay, so that the element of area. So you have an area by the name of dA. All right, so you have this dA. Okay, all right, so you have this dA, and over here you also have your dA there. So let's make the assumption. All right, make the let's assume. Okay, so the distance from the dA to the free surface. All right, dA to the free surface here, okay, is equal to we call it h then. All right, we call it as the h. Okay, all right, and of course when you have an area and then we have a fluid in front of it, so there must be a force. All right, so there must be a force acting on the area of dA here. Okay, so there must be a force. This force, all right, this red line there represent the force. There must be a very small force. Why? Because the area is an element of area, so the force must be element of force there. Okay, so you have the element of force. Okay, all right. So now, by looking at that figure there, we need to determine what is the dF. All right, so we write. We know that P, all right, pressure is equal to force divided by A, but you only have a small area, an element of area, so you have dA, and then of course you will have an element of force. In other words, we can write that dF is equal to P dA. All right, dF is equal to P dA. All right, so now we the magnitude is equal to P times the pressure at that particular point times the area of dA. So what pressure is that? All right, so in order to know the dF, we need to know the pressure at that particular point. So why don't we call that point as a point 2? All right, we call it as a point 2 here. All right, so over here actually is a point 2. So we write the dF is equal to P2 dA. Okay, so the next question is, what is the value of P2? We can determine the P2 if we know another point where the pressure is known. So in this case, the point where the pressure is known is on the free surface here at the top. Alright, so free surface at the top, here we call it as a point 1. Okay, so looking at that figure at the top there, we know that P2 actually is equal to, alright, P2 is equal to P1. This is equal to P1 plus your rho G and the distance between 1 and 2, which is H, and time the dA. Alright, these are definition. You have learned this in the previous video, how to measure a P. And we know that P1 in this case is open to atmosphere in terms of gauge. Alright, so this is equal to 0. So dF actually is equal to rho GH dA. That's the magnitude of force, element of force acting on the area of dA. Okay, but we're not looking for just this dA. All right, we want to determine the whole area of the plane surface. If you want to know what is the magnitude for the whole area of the surface, of course you need to do the integration. So integrate dF on the left and then integrate the whole area, and then we have a rho GH dA. Alright, rho GH dA, and the rho G is constant in this case, alright, because it is a water. Alright, it will not change from top to the bottom. Okay, so we put the rho G outside, so we integrate the whole area H dA. Alright, the H keep on changing from the top to the bottom. Okay, so finally we say, okay, so F is equal to rho G integration area H dA. Okay, and by the way, alright, if you want to know the magnitude, you say, okay, rho G integrate area H dA, and the mathematician have done this integration here. Alright, they have done this integration, alright, the rho integration area HdA, they call it at the first moment of an area, all right? We call it what? First moment of area, right? First moment of area, all right? So first moment of area is equal to h bar time A, okay? So h bar time A. So by that we can say the magnitude of the hydrostatic force on plane surface equal to rho g h bar time A. So this is the magnitude, all right, given by the fluid, all right, to a plane surface, rho g h bar time A. All right, rho g is the fluid which is giving the force. H bar, look at the figure there. H bar is what? Distance measured vertically, all right, vertically from center of gravity of a submerged surface to a free surface, all right, to a free surface. That is h bar. You need to remember that. And then time the area. What area is that? The area of the whole, if I draw it here, all right, is the whole body which is submerged, all right? So F equal to rho g h bar time A. Okay, now what happened is that if you can imagine it in 3D, actually, all right, when you can imagine it 3D, actually you can extend the line of this what you call our slanting body here, all right? What you need to do, just extend the line, all right? Extend the line until it cross the free surface, until it cross the free surface. After it cross the free surface, you draw a line which is perpendicular to that particular dotted line, okay? So draw a line which is 90 degree, all right, 90 degree. Call this as the O, and it's a line OX. So you have a line OX. This line OX actually is on the free surface, all right, but when you draw it, it seems like this OX is pointing into the water, but actually this OX actually is on the free surface, all right, on the free surface. Okay, so now since this is OX, of course the dotted line here, we call it as the y, right? So we call it as the y, right? The y axis. Okay, so this is the y axis, all right? So now since we have this new axis, so we can say that the distance from the DA, all right, the distance from the DA here, all right, okay, from the DA to our line OX here, okay, we call it as the y. Okay, the distance from OX to the center of gravity, all right, we call it as a y bar, all right, we call it as the y bar. So from the diagram there, okay, if I can draw the diagram, okay, so basically you will agree if I say it, we have this line, and then we have that blue line at the top, and then this another line. This is what we call point of CG, all right, when you measure to the line OX here, so the distance is y bar, all right, while from the CG to the free surface here, we call it as the h bar, and the angle of here is theta. Okay, this is a 90 degree, so you have another theta the other side. Okay, so the relationship between the h bar and y bar, we can say that h bar is equal to y bar sine theta. Okay, so you have one relation here, one relationship which state that h bar actually is equal to y bar sine theta. If you have that relationships, of course, finally you can say f can also be mentioned in terms of or measured in terms of rho g. The h bar now will become y bar sine theta times the a. All right, so you have two equations, all right, to calculate the forces given by the fluid, all right, whether you measure it vertically by using the H bar, so this is vertical, all right, use the vertical line, or you use the slanting, all right, so you have a slanting line, all right, so where you have the y-axis. Once again, you can memorize this equation, but you must understand what is the H bar. H bar, once again, is from the center of gravity of a submerged surface measured vertically to a free surface, and y bar is the distance from a center of gravity of a submerged surface to a line OX. How you create the line of OX? You just extend the body, all right, extend the body of a submerged surface into the free until it crossing the free surface, all right, this we call it as a free surface, all right, and then you draw a perpendicular line crossing that dotted extended line, all right. From there you have what we call the OX. Okay, so this is a very important factor which is you must understand. Okay, so what is y bar and what is the H bar? Okay, and once again, F equal to rho g H bar times A, or rho g y bar sine theta A. So you have the magnitude, all right, so you have your number one, which is the magnitude. Okay, in the next video I will show you how to determine the location.